make sure you're doing that. So that note needs to appear, otherwise you will lose 6 points by not creating that note. All right, now then go and make sure the title block reflects the established scale. I'm giving you this one right here. That's a freebie from us today. And the material will be the SAE 1020. Save, plot it, turn it in. Okay, now are there any questions from anybody about the first one on here? Yes, I know you just did this one in SolidWorks, and yes, I know it was fun and easy. But yes, you're going to do this for me anyway, and you're going to just simply enjoy it, aren't you?
It's way easier on this.
Yeah, it was actually kind of difficult.
SolidWorks.
Oh, I'm sorry. Well, then you'll enjoy this more then.
Exactly.
Okay.
I love AutoCAD.
Now the drawing's complete, so there's nothing you have to imagine or wish or wonder about this one. Just make sure you're giving the proper tolerances on here, and give me every single dimension that you see on here as well too. Okay? Any questions about this first problem? I will get it out of the way. Let's talk about number 26 now. Number 26 is one you're going to use it's another previous drawing on here. I warned you about this. What I want you to do is I want you to open up your drawing 18108. And that's this guy back here. It's that wonderful big old gear on here that we cut a section through. Now on here, I want you to use this as your template and save it to your directory as 18126. Again, if you did anything wrong on it, you must correct it. If there was anything that was incorrect, and modify your large detail to resemble the attached example detail as closely as possible. Now most people majors look as close to this as you could, but if you didn't, then you need to have this amount of geometry on it in order to be able to do what you have to do for this part of that detail. Now, on this drawing, this is a freebie. I'm going to give you this one. This is also 1-to-1. So go ahead and bring this thing in at 1-to-1 scale. Yes, you will need to create the node on here, as you see on this. It's expected. But the reason I mention is because of this. You know that what you did was you drew this all at regular full scale. So if I came over here and I dimensioned anything on here, oh, I see that you got scrunched. I got you covered here. 3, 2, 1, and you should be back. Gotcha? There we go. All right, so if I wanted to dimension this, remember dimensions go on the dimension layer, nothing weird about that. If I dimension it from here to there, I get the value I'm looking for. Please note, you do need to make sure you give me these diameter symbols as you see on here. Every dimension you see on here is how I want it on yours. Getting that diameter symbol is easy enough, just coming up here to your symbols and choosing diameter, and you've got it. What you need, okay? But that was at 1-to-1. What happens over here is this guy was blown up to double scale. So we're faced with a dilemma. If I've got to dimension this 0.3184 that you see right there, two things you must know about this. That was back to what we call the theoretic sharp corners. You see what I mean that right there? So what I had to do in order to dimension this, I had to go ahead and create that theoretic sharp corner, and then I had to go ahead and do my linear dimension between the two. So bear that in mind first of all. You can't do it to that position there at the end of the fillet. You got to do it to the theoretic sharp corner right there. So there's a number, but that number is clearly not the same as over here. Why? Because that one over there is 4-place decimal. Okay, let's fix that then, right? We'll change it to 4-place decimal. See if that makes a difference in our lives. Precision, 4-place. Did that change anything about the dimension? No, it did not. All right? So what has to happen here? Well, to many of you, this is a new concept. To anybody who's already taken the architectural drafting class, we had to do this for architectural. But beside the point, you need to know how to do this. Under our dimension style manager, back here, we'll do an override, because it's just going to pertain to these dimensions on that enlarged detail. Back here under primary units, not fit, primary units, you see right here where it says scale factor. Right now it's set at a scale of 100%. That's why we got the 1.375 that I just demonstrated to you. If I change that value right there to 0.5, what that does to me is this. I click OK, and I close it. What that does to me is this. It takes this and it says, okay, whatever that distance was from there to there, I'm going to automatically half the value. And that's how we can enlarge dimensions like so. So precision, 4 places, and now we get what we're looking for. See how that works? So again, I'll repeat it one more time so you see this. Dimension Style Manager, do an override. Back here under primary units, set the scale factor to be 0.5. What that does is it says, hey, this was 3 inches, I'm going to change it to be 1.5. It's going to take and halve any value you have. Now, that will work beautifully for you for this dimension right here. It'll work for that little fillet radius right there. These guys right here are a little bit of a nuisance. The degrees don't matter. It will not change the degree. It will not change any angles you have on there. That'll be absolutely fine. But when it comes to these guys right here, this is going to be a little weird for you because you see there's huge diametral dimensions and they're stuck inside this bubble. So what are we going to do there? Well, what we're gonna do is a couple things. Sometimes we find it necessary in our lives to take some liberties. That's the best way to put it here. So what I'm gonna do is, I'll leave that on the same half value on there. I'll go and do a diametral value, and I'll pick that right there, and I'll get what I'm looking for right there. Agreed? But look what happens. See that right there? It really kind of leaves the box, doesn't it? So sometimes we're left with a dilemma of how do we handle that situation in our lives. And what we'll do in this case is, and this is something I really advocate all the time, but go ahead and explode this dimension right there. That'll give you the opportunity then to trim away what you don't want. See how that works? So I'll trim it, take that away. Just like so. And I'm left with what I'm looking for on the inside. Now, can I do anything with that after I've exploded it? No, not at all. You're stuck with it now. You have to redo it if you want to do anything about it. Now, the other thing that happens is this. There's an arrow down there on the other end. If I do a zoom extents on there, it's absolutely fine. Let's see what happens when I go to print this thing. Okay? Note that sometimes, and it may not do it for me this time, but 204A on here, and I'm set to 11 by 17. Notice that sometimes it will actually give you trouble. In this case, it's not because I exploded it. But if I get a preview on here, it's absolutely fine. Yay, there it is. Well, mine's in color, but that's not the point. Anyway, if you find that you're getting your drawing is set like this, and it shows this point as part of your extents down there. Everybody see what I mean by that? Because sometimes it'll still read where the center point of that circle was down there. When you go to print that, just simply choose to do that window that we learned about last time. So come back here, and on the device, I'll have to set this up again, no problem, and 1 by 17. But when you go to do this, go ahead and do it with a window on it, as you see right there. Window it, and then make a window that's over your drawing from click to click down there, and then your preview will be absolutely fine. See how that works? So there's situations where you have to kind of adapt and adjust to what's happening in our environment. Again, notes necessary on here, it's given to you, make sure it shows up on your drawing as well too. And most importantly, if you did anything wrong on this, it has to be repaired. I'll be throwing a template back on it again, and you'll face what we call double jeopardy. You're gonna get the same points off again that you got off before, okay? Any questions about this particular drawing here? Not so horrible, is it? You learned something new, didn't you? Kinda neat. All right, I will get this out of the way then. And let's move on to number 27. Now, number 27 here, bring it up nice and big. Says we're going to start a new drawing, save it to our folder as 18127. We're going to correctly draw this rocker arm using the exact attached example. The best method to create this drawing is to draw both views as if there is no bend. Once they are completed, rotate the arm into the top view, or in the top view, in the correct position. What I mean is this. So what we're going to see is this particular drawing right here. Go ahead and draw. All done? Oh, great. Thanks. Appreciate it. I look forward to seeing you at that meeting. Well, the meeting we're going to have is a preview meeting on the 16th. Hope you read it. Great. Thank you very much. You need anything else from me? If you do, let me know. All right. Thanks, Ronnie. All right. What I mean by that is this. Best way to draw this problem is as follows. Simply create this bent arm right there. Rotate it around that point to where it's horizontal down here, like so. See what I mean by that? And I can find the exact angle. Was it 30 degrees? Let's type in 30, and there it is. Oh, went the wrong way. I went counterclockwise. I want to go clockwise. Undo that. Rotate again. And let me explain how this is going to work. Take that as my base point, and I'll tell it. There it is, negative 30. Now, on here, there it is. Go ahead and draw it like this, and then project it down to this view right here. That way we're kind of seeing all that stuff actual size. Then we can go ahead and rotate it up into position once it's all done. Then dimension it. Does this make sense? Now some things on here are going to seem a little weird on this drawing over here. Watch the lengths of these little runouts right here. And I don't want you to make a little runout for me at that position. I know there is one there. I'm not asking for it. I'm just asking you to show this at the position where it ends. That would be it right there. Show it coming down. So clearly, this is not where it's going to be here. It's going to be when it's rotated in position. So be aware of that fact. That line is not going to extend all the way to that point. It'll get shortened up when you get it to its real position. So I think it needs to get modified on here to try to add some type of resemblance of normalcy to it. Okay? But the only other thing on here I will mention to you is this. The spot face. See this little spot face right there? That's what that's called. This one over here seems to show it much deeper on there. Trust the numbers. Never trust the picture, trust the numbers. Does that make sense? If this tells you that it's got a spot face depth of spot face is going to be 0.1875, that means the depth of this guy right here is 0.1875. It's not gonna necessarily look like the picture, is it? Okay? So people freak out about that. They go, well, it's not deep enough. Is it the right number? Then you're fine. The only other thing on here is this. There is a fillet and round on here. See the radius of 429 on there? All right. What you're gonna have to do on this is this. See this dimension right here? Well, that dimension, that thickness right there, you're gonna go ahead and give me that tolerance on here. But what you're gonna do to get that line and to get that line is as follows. Take this line and offset it down 0.429. Take this line, offset it up 0.429. But Doug, that doesn't end up being, I understand that, okay? You cannot get this fillet right there if the distance from there to there is not 0.429. Does everybody follow me on this? You'll have to do the construction. And what I'm telling you is because of this tolerance and the radius of 0.429, offset 0.429, make your fillet, offset 0.429, make your fillet. Then when you go to dimension this guy, make sure its tolerances reads this. It may not give you that as an expression. If I measure it, it's going to say, oh, this is like 1.074, okay? Well, you need to modify this dimension right there so it reads 1.075 over 1.069. If you have to add or subtract, whatever you have to do, but I need that dimension to read as a tolerance for that bar, given the offsets of 0.429 both ways. Does this make sense? Okay, just giving you some heads up. Otherwise, when you're done with it, don't dimension it until you've rotated that position. You see the size, how it looks compared to the title block and border. Make sure yours is the same. Now, if you're looking for determining what the scale is going to be on here, I trust you. Trust me, I am not going to lead you down some weird stray of making it 3/4 of an inch equals a foot, or say whatever it may be. I'm not going to give you some weird scale. The scales you're going to have are going to be scales that are found inside your printer. You should be able to have every one of them the same, unless I tell you specifically what it's going to be. But I'm not going to make you do any weird 1.5 to 2s or something like that. Everybody understand what I mean by that? It's going to be 3s to 1s, 1 to 2s, 1 to 4s, 4 to 1s, 5 to 1s, things like that. Standard values of scaling. Okay? And if you're ever in doubt, ask me. Right here, note. See, it's attached to it. Make sure you complete the notes on here. Every one of these has had a note so far. So make a point of making sure you get the notes in every one of these drawings. Any questions now about this guy? The only other thing it says on here within the Dimension Style Manager, I do want you to create a new style on here. I want you to create a new style. So within your Dimension Style Manager, create a new style called Limits, starting with Mechanical Style as your template for all dimensions. Use that tolerance tab to set the lower and upper values for limits, tolerances, dimensions on here, and that's these guys back here. Make sure you set tolerance values for that one, and then use that style when you're doing dimensioning. Fully dimension and note the drawing exactly like the example, save, plot, and turn in. So I will be looking for a new style called Limits when I go to grade this guy, and I want to make sure you've used that style. That's why we learned how to do it, so you can make it for yourself. And this is the drawing I'm looking for. Any questions about this guy? Okay, great. Number 28. Now number 28, let me bring up that sheet right here. I want you to start a new drawing, call it 18128. Correctly draw the swivel plate using the attached example. Insert a B-size inch border and establish the proper scale, dimension settings, and text type. Complete the title block and border to show that properly in the information properly. Now, on this guy right here, and again, this is how big I want it to be on your drawing. I don't know what that scale is, you're going to tell me. Figure it out. On here, there's only one thing about this that requires a little bit of help. And that has to do with this situation right over here. See this guy right here? What's going to happen right here is this. I got a little demo for you, enlarged right here. These two circles are two different things. This guy right here, it says it's a radius of 0.375. Everybody see that right there? So I can draw a horizontal line. I can make a fill in 0.375 if I want to. It's absolutely fine. I get what I want. This guy down here, that is a hole that has the tolerance of 0.503 over 0.502. Everybody see how that works? Okay. Now, there's this line right here. This is a slope at 8 degrees. Everybody see that little slope of 8 degrees? Now, you cannot do this any easier or more efficient way than the way I'm going to show you right now. What you're going to do is, it's going to be at 8 degrees around the center of that circle. So what you're going to do is this. You're going to simply go ahead and rotate this line around the center point here and rotate it at 8 degrees. See what I mean? Just rotate it 8 degrees. I want it to remain tangent to that circle up there. See what I mean by that? I see how it's remaining tangent around there by taking it around that point. So just simply rotate it 8 degrees, and it'll go off in the direction you want. That's how we get that. Did you get scrunched, Brody? I'll fix you right now. I'll fix you real good. 3, 2, 1, you are fixed, right? So you see how that works? Now another problem we have when it comes to dimension this, if I want to do an angular dimension, I've got nothing up there to dimension 2. Did you know that? There's nothing up there to dimension 2. So if I want to make this angular dimension of 8 degrees, what I'm going to have to do is I'm going to have to supply some type of geometry up there. See it right there? So on the dimension layer, I create this line that was horizontal out there. Now that I've got that horizontal line, I can then go about doing my, I'll turn this one back so you see what I mean back there. There it is right there. I can then go about doing an angular dimension, there it is right there, between this piece of geometry I created and that line right there. That'll tell me my 8 degrees that I'm looking for back here. Just make sure that's all on the dimension layer. So it happens sometimes we're left with no other choice but then to have to create for ourselves a piece of reference geometry with which to make that angular dimension 2. And then you'll notice over here, see this big fat thick line right there on the top of the drawing over there? Is that really a big fat thick line? No, it happens to be those 2 lines right there that are in parallel, giving the top of the object and that corner you see right there.
Bless you.
So pay attention to that.
Bless you again.
All right, everything else on here should make sense to you. Just simply make sure you're giving me the proper dimensions on here. And again, another note on here you need to create on the text layer. Is there anything else in the notes up here worth mentioning on here? Nope, fully dimensioned note. And again, pay attention to what scale I'm asking you to make this guy. Right there is 28. I want it to be that big, so make sure you adjust your scale accordingly. Brent.
The larger swivel plate note, is there something telling us how big to make that text?
This guy right here?
Yes.
It'll be in your title block and border.
Oh.
He's asking about that extra text that was on there. And the extra text is just for reference on this drawing right here, and my drawing.
Yeah.
So you will not be putting that text on this drawing.
Oh, okay, alright.
It'll be down in your title block and border. Anytime you should see that on here, that belongs in your title block and border. Does that make sense?
Alright.
All right. All right, any other questions about number 28? Okay, not bad, we're crushing right along there. 29. That's big. Now this guy right here says to start a new drawing. We're going to call it number 29, and this is it right here. Again, correctly draw this ratchet spacer using the attached example. This is right down here. And again, this shows you how I want it to appear inside my drawing. I actually give you the title block and border on this one, so you scale that border so it looks the same for your example, please. Then, again, before you lay a single dimension on any drawing, you make sure you've established the scale first, or you're going to find yourself suffering for it later on. Establish the scale, get that title block and border onto it, then you dimension. My hope is this becomes habit for you. That you don't just draw something completely, then dimension it completely, and then go back and decide later on what the scale is going to be. It's the other way around. You can draw it all completely, establish the scale with that title block and border, then do your dimensioning on it. That should be your rationale, and that should become your habit when you're doing all the drawings you have to do. This has got no particular nuances to it, nothing on it that's any particular description is going to be cause for trouble on you, just establishing that dimension, scale on it, draw it, dimension as you see it, save it, plot it, and turn it in. So just when I show you on here what that's going to be. Incidentally, it's a very, very small thing. So you're going to make the scale on it very, very big. Also, please pay attention. You need to also make sure you are establishing your scale for your leaders as well too. Keep that in mind. Anytime I should see a leader on any of these drawings, that dimension scale will be affected on the leader. How do we do that? Just to remind you, under annotate, your leader manager is back here, and you can come back and modify it, and you can come back and set the scales for these guys as well too, back on these as well. Just like you did. Whatever you established for your dimension scale, do the same thing for your leader scale. Don't change the size of text, don't change the size of arrows, change the size of the scale, and that'll give you what you're looking for on there. Any questions about number 29? Oh, we're crushing right along today then, aren't we? Alright, let's talk about number 30 last one. Now 30, you're gonna be doing something you've not done before. And that's why I wanna talk about this guy real quick. You're gonna do something in here interesting. You're gonna draw the snarf bracket, the way you see it right there. Yes, we have fun naming these drawings when we do it. The snarf, you guys remember snarf from, what's that from, snarf from, Thundercats, right? And snarf. You guys don't remember snarf, okay, never mind. Watch Thundercats, okay? He was the little blue guy that said snarf all the time. Anyway, on here, what you're gonna do is directly create the snarf bracket. Notice that an A size border goes onto this, and you need to establish its scale. That's this guy back here. Alright, now, the snarf bracket is different because you're gonna notice that it has ordinate dimensions on here. Ordinate dimensions. Now, what are ordinate dimensions? Ordinate dimensions, we may have demonstrated for you long ago, but you've never had a chance to use it until now. Ordinate dimensions allow me to be able to, this is it right here, it allows me to establish its distances from a 0, 0 in x and y. That's it right there. Now, in order for this to work, this bottom corner right here needs to be set at 0, 0, that corner right there. So wherever you establish your entire drawing, it doesn't matter where, make sure that is 0, 0 right there. What happens next is this. I'll take this guy for example right here. To do an ordinate dimension, this is what it's going to look like. Make sure you look exactly like mine. I'm talking about that 0.875 dimension right there. The ordinate dimension right here simply says, okay, I'm going to pick my position on there, and notice that it tells me exactly how far away it is from 0. So that's all the x dimensions are going along here. All the y dimensions are going along here. So if I want to know that position right there, simple enough. Choose the ordinate dimension on here, click the location I'm looking for, and there it is, positioned at exactly as you see it on my drawing right there. That says that from that position right there, it's 0, 0. It's 1.625, it's 0.59, whatever it may be. See how that works?
And that has to be on the world 0, 0?
It has to be on your drawing 0, 0.
Okay.
Okay, so that's x and y. That is the origin right there.
Okay.
At that point. Now make sure you're not choosing that as your origin or that as your origin. It's going to be this corner that's been cut out. That's your 0, 0. And it'll tell you that if I choose ordinate dimension for it right there and bring it down. So again, make yours look like mine, and happiness will be yours. Yes, Frank?
What would the point of this be? Because it seems like hell to try to read if you were actually creating a part.
Yeah, well, if this is going to be milled by a machine that's reading an x and y coordinates,
Okay.
then that's exactly why.
Okay.
It needs to go to that position to do this, it needs to go to that
Okay.
position to do that, assuming that corner down there is 0, 0. That's the whole point of numeric control
And-
milling.
Whenever you start a milling project, you always pick
Yeah.
a 0, 0.
Yeah, I know with CNC. Yeah.
Yeah.
So that's what this is going to do. It's all
Even
reference to
manually.
that point. So you're
Yeah.
expecting a machine to mill it.
Okay.
That's why. The only thing on this one that I need to make 2 points on here. One is this one, it's easy enough. Make sure you get all the dimensions, folks. You'd be surprised how many people do this whole thing and don't finish it. They'll miss a dimension here, they'll miss a dimension there, completely forget to mention that. Or they don't, show these angular dimensions for some reason, they simply decide to skip them, whatever it may be, or the diameters of these holes. Make sure you get every single dimension on here. It's a quick and easy and silly way to lose points very rapidly. Now, please note that there is this right side view on here. Now, the right side view, if I don't give the instructions on here, no, just like the example. On here, you see I'm looking at center lines and object lines of those things I can see. Does that make sense? No hidden lines or center lines for things I don't see. I'm looking purely at center lines and object lines of those things that I do see. Yes, some of these don't have center marks on them. That's not up to you. Don't worry about it. You draw what you see, I'm okay with that. Everybody understand that? So, but there should be a center mark on here, Doug. Look, I just draw what you see. That's all I ask for, okay? Make sure you do that. But the other thing too is this. Notice over here, I do ask you for the thickness of this bar. And 0, 0 is suddenly at that point right there. How do I handle this? Well, what do you think? If I ask you to solve this without me giving you directions, how would you give me the ordinate dimensions for that side view you see right there?
Can you set the UCS?
No, you can't. There is a command called origin, and it can allow you to establish origin, but that doesn't always help in this case. Easiest thing to do is to just simply move your drawing, take that point, and move it to 0, 0.
That's great.
All right? And then you can go a dimension to it. All right? Does that make sense? Yeah, there is an origin command that can allow you to establish where origin base is at 0, 0, or wherever you want 0, 0 to be. But I find for this purpose it's just easier just to move the drawing to 0, 0, and then dimension those two things. Brent.
I'm curious just about, in AutoCAD, is there any way to actually like define a Z-axis so it would understand that?
Not in a 2D drawing. no.
Okay,
No, there are 3D, AutoCAD has its own 3D software.
okay.
It's called Inventor. Okay? And Inventor is usually, let's say, a release or two behind whatever SolidWorks is doing.
Okay,
So, and the reason why we used to teach Inventor here. We taught Inventor for probably up until the year 2000, and then that's when we got SolidWorks. And instead, because local industry asked for SolidWorks, they wanted SolidWorks.
yeah,
So, and actually Borg Warner, the engineering company Borg Warner, actually paid for us. They paid for the first SolidWorks that we got here. They paid at that time, in the year 2000, it was like $10,000 in the year 2000 to get SolidWorks into our lab.
that's crazy.
And then we just now pay maintenance on that every year to get latest upgrade. But they wanted us to teach this, and everybody else in the industry around here wanted SolidWorks as well too. You go to Detroit, it's gonna be different. It's gonna be different in Grand Rapids, it's certainly gonna be different in Chicago. Wherever you go, it's gonna be different. So it'll be different in Lansing for that matter.
I thought Autodesk was Fusion for you.
No, it's Inventor. Well, it's Fusion now, yeah. But we used to teach Inventor. So, yeah. But again, it's still at least a release or two behind SolidWorks, which is why we teach SolidWorks to be the latest and greatest. Okay? So, this is something new for you to try. Again, give me what you see, and I'm okay with that. There'll be no arguments with me about that. And that's it. That's all I've got for you. There's nothing more to have to do. Those are the only assignments we have for this particular set. I did not assign number 31, so don't worry about that, guys.